Okay. First question on the review was the easiest question you should have seen all year. Organize this information into a 3x2 matrix. There it is. That's it. Okay. Next one was not one I told you that you had to do manually, so you could use a calculator. On the test, if I have one like this, I expect you to use a calculator and either use Cramer's rule or inverse matrices. I don't expect you to use substitution or elimination, because the whole point of this chapter is using matrices to solve systems. Okay, so make sure that you know how to use Cramer's rule or the inverse method. But let's just do it by hand for practice. Okay, so we remember how to do Cramer's rule and how to find inverse. So let's do Cramer's rule first. So what I really have is I have a matrix that's my coefficients are this, right? And then my constants are this. Cramer's rule says you find the determinant of the coefficient matrix. Well, that's 10 minus a negative 9, so the same, it's 10 plus 9. Right? 10 minus negative 9. So I'm going to say that that is my denominator. To find x, I replace the x column with the constants. And to find y, I replace the y column with the constants. Make sure this is on. Yes. Okay, so now I've got to find two more determinants. 18 times 5 is 90, and minus 33, right? 18 times 5 minus a positive 33 is 90 minus 33, which is 57, right? And 57 over 19 is 3. Here I have negative 22 minus 18 times 3, 54. 22 and 54 is 76, which is negative 4. Okay, so using Cramer's rule, I found x to be 3, y to be negative 4. Okay, now let's try it the inverse method. Practice both methods here. First thing I need to do is find the inverse of this matrix. So I already found the determinant. It was 19. I put it 1 over that determinant, and then I multiply it by switching element 1 and 4, keeping element 2 and 3 the same, just changing the signs. Okay, so this becomes 5 19ths, 3 19ths, negative 3 19ths. I'm going to move this over. And 2 19ths. So that's my inverse matrix. 2 by 2. There's lots of fractions. Okay, and I'm going to multiply it by my constant matrix. Kind of clean that up here. Still with me? So I'm going to take 5 19ths times 18. No, I'm just going to use a calculator. 18 times 5, 90 over 19, minus 3 times negative, that's a positive then, or no, it's minus, sorry, plus a negative 33 over 19. 90 minus 33, I think we already did that. 57, and 57 over 19 is 3. So x is 3. And we do the second row. Negative 3 times 18 is negative 54. And then we have minus 22. And that becomes 76/19, which is negative 4. Same answer with the inverse method as the Cramer's rule. 3 and negative 4. Okay. On the test, this problem you can do a calculator. I just wanted to go through how to use Cramer's rule and find inverses for review. All right. Number 3, just a subtraction problem. There's really not much work to show. I first have to make sure it's the same dimensions. So this is a 2 by 4 and this is a 2 by 4. So I can subtract. And I'm just going to subtract each element in each matrix. So 6 minus 10 is negative 4. 3 minus a negative 5 is positive 8. 10 minus 3 is 7. 4 minus 1 is 3. 3 minus 9 is negative 6. 2 plus 4 is 6. Negative 5 minus 0 is negative 5. And then 6 plus 2 is 8. That should be it. Next one is an addition. And again, I need to check. Not possible. So that one's a 2 by 4. This was a 2 by 3. Or I have to write impossible, I guess, if it doesn't exist. Next, I've got scalars. So first thing I'm going to do is go ahead and multiply through. So 4 times 2 is 8. 4 times 1 is 4. 4 times 9 is 36. And 4 times 12 is 48. And 2 times negative 5 is negative 10. 2 times 8 is 16. 2 times 7 is 14. And 2 times 0 is 0. You could have multiplied through by negative 2 and then added them. It works either way. I just decided to multiply by 2 and then keep the subtraction sign. So now I'm just going to subtract. 8 minus negative 10 is 18. 4 minus 16 is negative 12. 36 minus 14 is 22. And 48 minus 0 is 48. Questions on that one? Okay, same kind of thing here, except this time I have a 3 by 1. So I'm going to go ahead and multiply everything through first. 0, negative 28, plus 30, 5, and negative 10. I'll go ahead and do the minus this time, minus 3, and make it a positive just to show you the difference. Negative 3 times 10 is negative 30. Negative 3 times 4 is negative 12. Negative 3 times negative 1 is a positive 3. And now I can add all of these together. 21 plus 30 minus 30 is just 21. 0 plus 5 minus 12 is negative 7. Negative 28 minus 10 is negative 38. Plus 3, negative 35. Just be really precise with your numbers. Make sure that you've remembered to multiply by the negatives when they're negative. You should be fine. These are easy, but there's lots of places for little errors. So just be really careful on your math. All right, number 7, determine whether a 3 by 5 times a 5 by 9 is defined. So these two are the same, so it is, and the resulting matrix is a 3 by 9. So the answer is yes, and it's a 3 by 9. Okay, now we've got a multiplication. First I need to figure out if it's possible. This is a 2 by 2, this is a 2 by 3. So it is possible, and I'm going to have a 2 by 3 when I'm done. So I'm going to go ahead and just draw my 2 by 3 to help me remember how many elements I need. Okay, so for the first cell in my new 2 by 3, I'm going to take the first row by the first column. 4 times 9 is 36, minus 2 is 34. For my second cell, I take the first row, second column. 4 times negative 8 is negative 32, plus 4 is negative 28. 4 times 1 is 4, plus 6 is 10. 2 times 9 is 18, minus 10 is 8. 2 times negative 8 is negative 16, plus 20 is positive 4. 2 times 1 is 2, plus 30 is 32. So that's my matrix. Okay. We were allowed to use a graphing calculator on this one. All you do for the graphing calculator is plug in A, in the edit, plug in B, and then on a clear screen, just take A times B. But let's do it without for practice. Okay. So first thing I'm going to do is multiply A times B. So it's going to be a 2 by 2. 3 times 5 is 15, minus 6 is 9. 3 times negative 3 is negative 9, plus 1 is negative 8. 0 plus 24, that's an 8. And 0 minus 4. So that's A times B. Then I'm going to multiply that by C. Nine times 0, negative 56. 9 times negative 2 is negative 18. Minus 24, 42. Twenty-four times 0 is 0, minus 28. And then 24 times negative 2 is negative 48, minus 12 is negative 60. So A times B times C is this matrix. Okay, now I'm going to multiply B times C. So let's do that here. B times C, 5 times 0, negative 21. Negative 10 minus 9, 0, 7, and 12 plus 3 is 15. And I'm going to put that on, this is B times C, and A has to go to the right of that. Right? Now 3 times negative 21 is negative 63. No, negative 63 plus 7 is negative 56. 3 times negative 19 plus 15. 3 times negative 19 is what? 37? 57. 57. Negative 57 plus 15 is negative 42. 0 minus 28, and 0 minus 60. They are the same. What does this tell us about matrix multiplication? Which property did this represent here? Not commutative. Commutative is the order. Associative. So matrix multiplication, the associative property does work. Does not work on commutative. The order matters. But the associative property works. Okay? All right, determinants. This is a 2 by 2. So I multiply these together to get 77. Then I subtract the product of this. And 29. I don't know. My mental math skills today are not working. 77 minus 48. They are working. Okay, now expansion by minors, forget, this is just the way we know how to do it. Okay, there's 2 ways to do it. Expansion by minors and the diagonal method. We only learned the diagonal, so hopefully you just did the diagonal here and didn't research what expansion by minors was. Okay, so what I'm going to do is rewrite this, and then rewrite the first two columns. I'll use a red pen to help me out. So I have this diagonal first. 6, someone do these for me as I go. 6 times 9 times 4. 260? 16. And 1 times, I should be able to do that one. Minus 6. And this is what, 20 times 8, which is 320, 360, right? 20 times 8, sorry, 160. Positive. Then I subtract this diagonal, this diagonal, this diagonal. So the first diagonal, 18 times 4. Second diagonal, negative 8 times negative 3 times 6. So this is 24 times 6. 444? 144. I thought you said 44 the first time. Okay, and then negative 20. Okay, so take 216 minus 6, that's 210, plus 160. 370 minus 72 plus 144 minus 20. 196, and it's positive. So what's 370 minus 196? 174. Okay, everybody take just a quick minute and find the determinant of this with the calculator to check it. So we're going to go second matrix, over to edit, make it a 3 by 3 if it's not already, and then enter your numbers. And then clear your screen and go second matrix, math, determinant, and then pull that one in. 174. So use your calculator tomorrow and check it, but I need to see work here to give you credit, not just the answer. Okay? Anybody need me to walk through how to find the determinant again on the calculator? Okay. So go second matrix, go over to edit, and then enter your 3 by 3 in matrix A. And then just put the numbers 614, negative 59, negative 3, 2, negative 84. Okay, so once it's in there, just go second mode to clear your screen. You see that? Okay, and now we're going to go second matrix over to math. And the very first selection is DET with a parenthesis. Click on that, and then do second matrix, names, bring A in by just hitting enter. And then you have the determinant of A. Okay, and then you'll just hit enter again and you get the number. Does that make sense? Yeah. Everybody good? Okay, so let's keep going here. Kramer's, oh, we've got a geometry, area of a triangle. Okay, so for the area of a triangle, you take the determinant of the points. Those are the X and Y columns, so I'm going to write the points down. And if I could do this right, 7, negative 1, 1, 6, 5, negative 3. The last column is just ones. Okay, you're going to take this, you're going to find the determinant, you're going to multiply it by either positive or negative 1/2. The positive or negative just means your answer has to be positive because area is a positive number. You don't have negative area normally. Okay, so the plus or minus, don't get confused by that. If your answer when you divide it by 2 or multiply by 1/2 is still negative, just make it positive. It's almost like taking the absolute value of it. Okay? Huh?
What if you get 0?
If the determinant is 0?
Like your whole answer.
So the determinant's 0.
Yes.
Then there's no area. It's not a triangle. But let's go ahead and practice. Second matrix, over to edit, enter my numbers, 1, 6, 1, 5, negative 3, 1. Then clear my screen, go to math, determinant, bring that one in. I get negative 100. So that means my area is 50. Okay, divide it by 2, make it positive. Everybody get that?
Yeah.
We're all good? Okay. I will let you on tomorrow's test. On the test, I've written in the margin which ones you need to do by hand. Okay, so just make sure if it requires work, that work is shown. If it doesn't say by hand, you can use the calculator. And the geometry question like this one on the test tomorrow, you can use the calculator. The one that's coming up here with Kramer's rule, you may use a calculator, but I need to see how you set it up. Okay, because I don't want you to just use the inverse method. I specifically am asking you to use Kramer's rule on these two. Okay, so let's set them up. For the 2 by 2, x equals 6.5 to 10, negative 1.5, divided by 3, 2, 2, negative 1.5. Everybody see that? The denominator is your coefficients. Your numerator is the coefficients, but the x column's been replaced by the constant. Okay? And then y equals 3, 2, 6.5, 10 over the same determinant on the bottom. Okay? This is what I need to see on the test. From there, you can use the calculator if you want to. 2 by 2s are normally pretty easy, but sometimes with the decimal in there, if you feel more comfortable using the calculator, you can. Okay, so let's just do it with a calculator. I'm going to enter, what I'm going to do is enter 3 matrices. The numerator for the x, the numerator for the y, and the denominator for both. Does that make sense? Okay, so I'm going to go to matrix, edit. This time it's got to be a 2 by 2. And I just enter x's, 6.5, 2, 10, negative 1.5. Okay, then I'm going to do the same thing. Go over to edit, go down to B, make it a 2 by 2. And enter y, 3, 6.5, 2, 10. Do the same thing again, and go down to C, make sure it's a 2 by 2, and enter the denominator. Okay, once I have all 3 entered, I'm just going to go to a clear screen. I'm going to take the matrix A and divide it by matrix C. Oh, a determinant. Sorry, got to do the determinant.
Which one did you put in?
What's that?
I see you put it for B, which...
A, I put in x, B, I put in y, C, I put in the denominator. Now I've got to take the determinant of, so I'm going to go matrix, math, determinant, bring in A, end parentheses, divided by, do the same thing now, matrix, determinant, C, end parentheses, enter. I get 3.5 for x. Everybody get that? Then I do the same thing. Determinant of B, end parentheses, divided by determinant of C. And I got negative 2.
So you do A divided by C?
Determinant of A divided by determinant of C. And notice when you do determinant, it has an open parenthesis, so you've got to close that parenthesis before you divide. Determinant, so you go to math.
Exactly.
You've got to close the parenthesis after A.
Oh, after A.
Yeah, because
Okay.
determinant of A is on top, and then you've got to do determinant of C on the bottom, not just C.
Determinant.
Determinant of A, close your parenthesis, divided by
Divide.
determinant
Determinant.
of C.
C. Okay.
I said I was gonna say, but I slept instead.
Go down to C. Yep, enter. Okay? All right. So the same thing with 14. I just need to see how you set it up. And you can do it with a calculator. Yes. Okay, so my x is going to be 27, negative 37, 30, negative 5, 3, negative 2, 3, negative 7, and 5. And it's going to be divided by the coefficient matrix, which is 2, negative 5, 3, 4, 3, negative 7. Sorry, I'm writing over things, but I'm running out of room. My coefficient matrix, right? And then from there, calculator. All right. Then for y, all I'm going to do is replace y with my constants, and x that I had before goes back to the original coefficients of 2, 4, 1. Okay, and then z I replace with the constants, and this goes back to whatever to negative 5, 3, negative 2. Okay, so I need to see all three set up, x, y, and z. And after that, you can use a calculator. Okay, but remember, in the calculator, you're going to do the determinant, the matrix, end parentheses, divided by determinant, and then whatever. If it's C, then do C. Okay? This is really important, end parentheses, because it automatically has an open parenthesis when it pulls the determinant end. If you don't end the parentheses, it's going to take the determinant of the matrix A divided by the determinant of C altogether. You know what I mean? It follows the order of operations. So you've got to close the parenthesis to say, I'm done with the numerator. This is what I want in the denominator. Okay? But other than that, this is really a lot easier than doing 3 by 3 determinants by hand. And you've already earlier in the test showed me you know how to do that, so I'm not going to make you do it again. All right. Determine whether these two are inverses. How do we do that? We're going to multiply them together, and if they give you the identity matrix, which is that, then they are inverses. Okay, so what I've got to do is multiply one half and negative 1/4. Okay, so 3 times negative 1/6, negative 1/2. 3 times negative 1/6, negative 1/2. 3 times 1/2. 3 halves, right? So I have negative 1/2 plus 3 halves. What's that equal? 1, thank you. Equals 2 over 2, right? Which is just 1. So there's the first one. 3 times 1/4 is 3/4. 3/4. Minus 3/4. There's 0. Keep going. 6 times negative 1/6 is negative 1 plus 1. Sure enough, 0. 6 times 1/4 is, what, 3 halves? And then minus 1/2 is 1. Sorry, 2 over 2, which is 1. So these two are, in fact, inverses of each other. Okay, you have to do that one by hand so that I can see that you get 1, 0, 0, 1. Okay, next one, finding the inverse of a 2 by 2. Just for review, the first thing we do is check the determinant. If the determinant is 0, it's called a singular matrix. You can't find the inverse of it. Okay, so my determinant here is 16 minus 8. Well, so I can find the inverse because it is in fact not 0. 16 minus 8 is 8, so I'm going to take 1 over 8, and I'm going to multiply it by 4 and 4. I switched those, but they're the same numbers, so you didn't notice that I switched them. But I did. And negative 2, I didn't switch those, I just changed the signs. Okay. So I'm just going to bring this in. 4 over 8 is 1/2. Negative 2 over 8 is negative 1/4. Negative 2 over 8, negative 1/4, and 1/2. And there is my inverse. That's it. Okay. Next one, solve the matrix equation using inverse matrices. I didn't require that you did this one by hand. Okay, so all we have to do to solve for x and y, I'm going to multiply this side by the inverse, right? So I have to do the same to the left of this one. So in a calculator, you're going to type in matrix, go to edit, make sure it's a 2 by 2, type in the matrix that you want to take the inverse of, which is negative 2, 3, negative 1, 3. Okay, go and do your constant matrix, make that B. So it's a 2 by 1. Change that. And then type in 5 and 4. And then clear your screen. So all you're going to do is bring in A, raise it to the negative 1, which is the same as the matrix button you've been using. Multiply it by B. And I get negative 1, 1. Everybody know how to do that on the calculator? That's from 4-7. We good? Okay. Transportation, it says they just want to write a matrix equation. So in order to use inverse matrices to solve systems, you have to be able to understand how to write a matrix equation. Okay? And the matrix equation is going to be the coefficients of your variables times the matrix of your variables and set that equal to your constant matrix. Okay? So to do this, the first thing you're going to do is figure out what your real equations are. Okay. So what I've got is cars, trucks, and vans. So I'm going to use C, T, and V instead of X, Y, and Z, just to keep things straight. Cars, trucks, and vans. And there's a total of 366. Okay? I'm going to need 3 equations. I have 3 unknowns, so I've got to have 3 equations. So my next equation, it says twice as many trucks as vans. So to get this straight, this is what I always do. If I had 10 vans, how many trucks would I have? 20. And how did I get 20? Multiplied what by 2? Vans or trucks?
Trucks.
Vans. So I had 10 vans. I multiply it by 2, and that gives me trucks. So I know that the number of trucks equals 2 times the number of vans. I always get confused when I do these, so I always have to throw numbers in for myself so I get them right. Okay, then we also know 186 more cars than vans. So cars is equal to vans plus 186. Okay, so I have my 3 equations. So now what I need to do is get all the things with my variables on one side, everything with constants on the other. Okay, so this one's already set for me. Okay, to do this one though, I've got to subtract 2v, right? And I'm going to do it, let's just write these again over here. Because I want to keep my variables in the same order. So I'm going to subtract 2v, and I still have a t, and that's equal to 0 now. Because I moved it over and I don't have a constant on the other side. Everybody see that? Okay. Here, my constant's 186, so I just need to subtract the v. And I have a c. 186. Okay. So really, there's a 0c and a 0t, but I'm just going to leave them blank. What did I do? Okay, everybody see those three equations now? I've got all the constants on the right and the variables on the left. Okay, so now in order to write my matrix equation, I'm going to just erase this. What are my coefficients in front of c, t, and v in the first row? 1. What are my coefficients in the second row? And the third? So there's my coefficient matrix. This is my variable matrix. And then I set that equal to my constant matrix. And I'm done. This is a matrix equation. Okay. If I wanted to solve now, I would just plug this matrix in, take the inverse of it, and multiply it by the constant matrix. Okay. So setting up your matrix equations is the first step in actually using the inverse process on the calculator. So if you can learn how to do that, and most of the time, if it's let me find an equation here, like the very first one we did. When they're set up like this, it's not quite a matrix equation. The true matrix equation would have been right? But if you just look at these two equations, two unknowns, everybody at this point should be pretty comfortable with all you do is you plug 2, -3, 3, 5 in your calculator for matrix A, 18, -11 in your calculator for matrix B, take the inverse of A times B. Right? So you don't necessarily need to take the extra effort of writing that matrix equation, but this is how we find the inverse using matrices to solve systems. Make sense? Okay. Last one is the bonus. This one you couldn't use a calculator because calculator doesn't recognize variables. So we actually had to do the determinant here manually. So I'm just going to repeat. Right? The diagonals. I did that wrong. That's supposed to be the 1, and that's 0. So x times -y times -1 is -xy. -y times 1 is -y. And 1 times -x times 0 is 0. Then I'm going to go the other way. -y times 1, x times 1 times 0, -y times -x times 1 is plus xy. Right? So I have -xy minus xy. That's -2 xy. I have -y plus y is 0, and I have 0 plus 0 is 0. There's my answer. -2 xy. Okay. Test is tomorrow. I will not be here. Mrs. Fennell will be here. But on the test that I left for her, like I said, I did write in the margin which ones you must show your work. Any questions on any of the material in this chapter that you want to go over in the next 3 or 4 minutes? Okay. This is recorded. I'll put it on Canvas. So if you want to go through it again tonight to prepare, you may. Okay. And that is that.